Okay, in today's video, we're going to look at a question on Euclidean geometry for both grade 11 and grade 12. Okay, let's read the question. In the diagram below, O is the center of the circle. Okay, center is a key word there. And then BD is the diameter of the circle. And we also told that GEH is a tangent to the circle. So that's another key word. And they gave us angle E1 to be 32 and angle E3 to be 56. So that's E3 being 56 degrees. Okay, so center of the circle, you think of things like angle at the center twice angle at the circumference. Okay, which you don't have here, but we have a diameter. This is our diameter. Then we look at the angle that is subtended by this diameter. So if I go this way and that way, you can see that E2 and E3 are subtended by the diameter. So that's the angle in the semicircle, which is 90 degrees. Okay, what else do we have? The tangent. Tangent, we normally look for tan chord theorem, tangent perpendicular to radius, or tangent from the same point. But here we only have a tan chord theorem. So this is the tangent, there's the chord, angle between tangent and the chord is E1 equal to which angle? We look at the angle that is subtended by this chord. Angle that's subtended by this chord, which will be what? Draw a line, this is where the lines meet, which is B2. So meaning that B2 is also 32 degrees by tan chord theorem. Okay, then next we look for the cyclic chord. There are a couple of them. The first one is this cyclic chord. Okay, so FBDE is a cyclic chord. That's the first cyclic chord. The other cyclic chord is this one. Okay, so let me use a different color here. So this is the second cyclic chord, meaning that this angle E2 goes with angle B3, those are the angles in the same segment, and also angle D goes with angle C, that's angles in the same segment. Okay, the last cyclic chord, I'm going to do this in orange, so there's the cyclic chord, FBCE. So meaning that angle F plus C will add up to, it's going to be 180 degrees. Same apply to this, and that will give us 180 degrees. Okay, so now we can start answering the questions. So question number 1, they want us to get the value of angle E2. So angle E2 is this one. We know that angle E2 plus angle E3 is equal to 90 degrees, being angle in semicircle. So therefore, angle E2 is equal to 90 minus 56. And 90 minus 56 is going to give us 34 degrees. So that's 34 degrees. So E2 is 34 degrees. Let's update. This one, B3 is also 34 degrees. That's angles in the same segment, by the way. So we have answered this question. The next question is asking for EBC. So there's E, angle BC. Okay, so this is quite simple because we basically are asking for angle B2 and B3. So we just need to show how we got the 34 degrees. So we'll say that's 1.2. Angle B3 is equal to 34 degrees. I'm using the pink cyclic chord. So angle P3 is 34 degrees. That will be angles in same segment. So therefore, E angle BC is equal to 32 plus 34 degrees, which is 66 degrees. Okay, in fact, I should have mentioned that angle B2 is 32 degrees by tan chord. Should have mentioned that angle B2 is 32 degrees. That would be tan chord theorem. Okay, so we have the 32 degrees from tan chord, 34 degrees, angles in the same segment. So when you add them, we get the 66 degrees. Okay. Then the last question is asking for angle F. So angle F being this one. Okay. So in order to get angle F, we need to work out angle C so that we can do opposite angles of a cyclic chord. Okay, that is quite simple because we already have two angles in this triangle. In triangle BEC, we already have two angles. So we can say therefore angle C is equal to 180 minus 56 minus 66, which will be the sum of angles in a triangle. Okay, so now 180 minus 56 minus 66, that gives us 58 degrees. So this is 58 degrees, meaning angle D is also 58 degrees. Therefore, angle F using this cyclic chord is going to be 180 minus 58 degrees. So we'll say angle F is equal to 180 minus 58 degrees, reason being opposite angles of a cyclic chord. Okay, so therefore angle F is equal to 180 minus 58, that gives us 122 degrees. Okay, so that's the end of that question.